So let's go over the solution to the practice problem for calculating stream discharge. We have a really simple stream here. It's 10 meters wide and we're told to use just 5 sections. And so simple math is going to show us that each section is going to be, if we divide it into 5 equal sections, that each section is going to be 2 meters wide, right? So we have 5 sections here, equally spaced. Each distance here is 2 meters. And to do this problem, remember how this works. We're going to, for each section, so each section I, we're going to calculate the discharge through that section Q sub I using the formula that Q is equal to the average velocity through that section times the cross-sectional area A sub I. And we're going to get the average velocity by taking the velocity at the midpoint of each section at a predetermined depth. If the depth, the actual depth, is less than or equal to 1 meter, then we're going to estimate the average velocity as being the velocity at 60% of the total depth. If the depth is greater than 1 meter, then we're going to take the average velocity as the average of the velocity at 20%, V20, and the velocity at 80% of the total depth. So I'll show you how to do those. We're going to use the attached spreadsheet, which gives us the velocities at the river for every point and depth in the river to do those calculations. So first of all, let's figure out where the midpoints are. That should be pretty easy. If this is 10 meters wide, then if this is 0, right, then that's 2, 4, 6, 8, and then 10 meters across. And so the midpoints, I'll draw them in red here. The midpoint here is going to be at 1, then 3, 5, 7, and 9 meters away from the left bank. So we'll call this section 1, 2, 3, 4, 5. That was our instructions. And the midpoint here, I'm just putting the midpoint just to remind myself, that's 1 meter from the left bank, 3 meters, 5 meters, 7 meters, and 9 meters. So let's work on this first section here, the one that's the one on the left here, this one over. I'm going to do this one over here, right? This one over here. Let's work on this one over here. So we're going to, the midpoint is at 1 meter. And so now we're going to go to our spreadsheet to determine both the depth at the midpoint and the average velocity along in that section. So here's the spreadsheet program you're going to use. Reminds us that the stream is 10 meters wide. We want to go in 1 meter from the left bank. And here you go. It tells us that our stream depth is 0.25, so I can put that into my table if I want. The depth is 0.25. Okay, I wrote it in there. And now I need to get the average velocity. And since 0.25 is less than 1 meter, all I need to do is go down 60% of 0.25 and get the velocity. So here's what we're going to do. We're going to use this area in the center as sort of our calculator. So I want to go down 60%, so that's 0.6 times the depth, which is 0.25, which is 0.15. So I'm going to now enter a depth of 0.15, and I get a velocity of 0.024. That's all I need to know. That's the average velocity in that first section. So I'm going to put that in here, 0.024. Let's just finish this thing out now. The area of this section is going to be equal to the width, which is always 2. Remember, 2, 4, 6, 8, 10. So the width is equal to 2 times the average depth, which is going to be the depth at the midpoint, which was 0.25. I can actually do that in my head. So 2 times 0.25, I'm going to multiply these two numbers together, and I'm going to get 0.50 meters squared. This, by the way, was meters per second. I should have written that in there. And then to get Q, I multiply 0.50 times 0.024, and that is 0.012 cubic meters per second, right? I'm multiplying square meters times meters per second. So there you go. That's my first section. So let's go on and do some others here. If I go to 3 meters, which is the center of my next one, I'm going to get a depth of 0.59. So once again, I can just use the 60% of the depth method. So I'm just going to equal 0.6 times 0.59, right? And so the depth I'm going to want is 0.354. And there we go. So my depth is 0.59 and my velocity is 0.128. So my area is 2 meters times 0.59 or 1.08. And my discharge multiplying the area times the velocity is 0.151 cubic meters per second. All right, and let's go and do the next few here. So the next midpoint is 5 meters across. I put in 5, and I'm going to get a depth now of 1.06. So with a depth of 1.06 now, I'm going to have to use a different formula. So now I need to calculate here. I need to calculate the velocity at, I need the depth at 20% of that, and I need the depth at 80% of that, and then I need to calculate the velocity at those depths. So let's first calculate the depth. So 20% of 1.06 is equal to 0.2 times 1.06. So that's 0.212, and 80% of 1.06 is 8.848. So now I'm going to use those values of the depth here. So I'll put the depth in here at 2.12, and my velocity at 20% is 0.607 meters per second. And I'm going to put in the depth of 80% of 8.8, and my velocity there is 0.227. So my average velocity is going to be the average of those two numbers. So I might as well just calculate all this in here while I've got the spreadsheet. It makes calculations easier. So I want, I just can use the average function if I want, of H7 to H8. And there it is. It's 0.417. So let's enter those data. So my depth is 0.227, and my average velocity is 0.417. Oops, I said that wrong. My depth is 1.06 and my velocity is 0.417. So here I've entered those data now. So once again, my area is going to be 2 meters times my depth times 1.06, which is equal to 2.12 meters squared. Multiplying that by the average velocity, I get a discharge through the third section of 0.884. So 0.884 cubic meters per second. And I'm going to do the same thing for the last two sections here. I'll just fill these in quickly. Okay, you'll notice that for the last two cells, the average depth was over 1 meter, so I had to use the formula that takes the average of the velocities at 20% and 80% of the depth to calculate the velocities, and then I've carried out all the other operations. And so we're almost done. All we need to do now is simply add up all of the contributions here and find the sum of each of these contributions to get the total stream discharge. So this is the total discharge of the stream in cubic meters per second, and it's going to be I'm just going to do it to two significant figures here, 4.3, again, cubic meters per second. So that's how you go about calculating stream discharge using the Q equals VA formula.